Hi Math Apps Nation, this is day 9 of chapter P. We're going to talk about some factoring. So for the most part, this should be review. Maybe I'll give you some good tips and tricks for next time. But if you are having any questions with factoring, please make sure you get them answered ASAP. So first thing you want to do whenever you factor is look for the GCF. The GCF stands for greatest common factor. This will make your life so much easier if you look for it first. So first off, looking at this first example, 24 a to the fourth b cubed plus 12 blah blah blah, right? A lot of things. Let's look at each term in particular and see the greatest common factor I can divide out. So I'm looking specifically at the 24, 12, and at the 18. Well, 24, 12, and 18. The greatest common factor that they share, now think about multiplication, would be 6. Each of those I can take a factor of 6 out. So 6 is becoming the greatest common factor for my coefficient. Next, I'm going to look at my a values. So I have a to the fourth, a cubed, a to the second. The greatest amount of a's I can take out is 2, because the last term only has a squared. So a squared, a to the second power, is the greatest common factor between my a terms. Last but not least, we have our b's. So we have b cubed, b to the fourth, b to the fifth. The smallest amount of b's that I can take out, the largest amount of b's I can take out is going to be b cubed, because the first term has b cubed. The rest have terms that are bigger than that. So doing that, it's like, great, that's awesome. Now I have to factor out each term. So from here, I have to divide out your greatest common factor. 24 divided by 6 is 4. A to the fourth divided by a squared, remember you subtract exponents. And b cubed divided by b cubed is 1. It goes away. Looking at your next term, 12 a cubed b to the fourth, divide out your greatest common factor. 12 divided by 6 is 2. A cubed divided by a squared leaves you 1a. And b to the fourth divided by b cubed is 1b. Last term, you'll get negative 3. Your a values will cancel, and you'll have b squared. So that's factoring out the GCF, the greatest common factor, which is this term right here. Next one, looking at these, I'm like, oh gosh, do I have to FOIL and then simplify? That's a pain. Keep in mind, they both have this term, 3x minus y, in both terms. So get that bad boy out of here. If I factor it out, then left over in my first term is a 2x plus 7. Left over in my second term here is 3x plus 2. I can combine those two terms because it's just adding. Nothing happens with my greatest common factor. But in here, I'll combine my x's. 2x's and 3x's is 5x. 7 plus 2 is 9. Then you're done. So please look for that greatest common factor first. Then our next chunk is factoring x squared plus bx plus c, or ax squared plus bx plus c, noting that the polynomial will factor if this, what another term is the discriminant, or what's under that square root in the quadratic formula, is a perfect square. So let's look. Here, I like to think of x squared minus 9x plus 18. You want to figure out what terms add to negative 9 and multiply to 18. If you need to write out factors to the right, please do so. But to me, I'm jumping to the fact that, hey, negative 3 and negative 6 add to negative 9, and look at that, they multiply to 18. You just factored. Number 4, what adds to 2 multiplies to negative 24. Again, you can write out your factors of 24 if you want. You'll see it's going to be x minus 4 and x plus 6. When you add them together, you'll still get a positive 2. When you multiply, you'll get a negative 24. Add to negative 6, multiply to negative 27. Whew. Factors of 27? Well, there's 9 and 3 that work. This time the 9's going to be negative because I'm going to get a negative 6 when I add them together. So the negative has to go with the bigger number because I'm going to get a negative. For number 6, when you have a value of a, so let's make this specific. These are all 1s in front, right? A value is 1. Well, in this case, the a value is 6. So I can't just look at what adds and multiplies. I have to do what's called split the middle. Now, this might be a different way to learn it than you have in the past, so if you prefer a different method, go for it. But this is what I'm going to show us right now. Split the middle means you're going to take your a value, multiply it by your c value, and now find terms that add to negative 13 and multiply to 30. I am splitting that middle term. So 6x squared stays, the plus 5 stays, and now I'm breaking up this term into 2. Split the middle. Well, what terms multiply to 30, add to negative 13? Well, that's negative 3x and negative 10x. The order does not matter. From here, you're going to take the GCF of your first 2 terms. Again, look at how it builds. Greatest common factor I can take out is a 3x, leaving you with 2x minus 1. Greatest common factor in your second group of terms is going to be 5. But we want to make sure that what's left over matches. So instead of me taking out just a positive 5, I'm going to go one step further. Take out a negative 5. And notice now that they match. That's crucial. If they don't match, then play around with that sign in front. Now this looks just like part 1. It has the 2x minus 1 in both terms, so get that bad boy out of there. What's left over in my first term is 3x. What's left over in my second term is minus 5. And a good way to check, if you ever want to check, is just FOIL it back together, and you should get the original problem. That will also help you with the signs in case you're having trouble with that. Always just FOIL and check back. Here's another one where we're going to do split the middle because the a value right here is not 1. So that is the big takeaway that, oh, that's not 1. I need to split the middle. Let's do it again. Take your first times your last term, your a times your c. And we're going to find terms that add to negative 22 and multiply to 72. The 3x squared stays, the plus 24 stays, but I'm splitting my middle term. No longer is it going to be negative 22x, but it's going to be 2 terms. Add to negative 22, multiply to 72. Well, that will be negative 4x and negative 18x. I have 4 terms, so I'm going to group and find the GCF. Well, in the first term, the coefficients 3 and 4 have no common factor, so we can take out an x. I mean, that's something. 3x minus 4. Here I can take out a 6, but again, I'm going to take out a negative 6 because I want these to match. 3x minus 4, 3x minus 4. If they don't match, play around. You didn't maybe pull out the greatest common factor, or maybe your signs has a little error. Now that they both have 3x minus 4, get that bad boy out of there, factor it out. What's left in the first term is x and a minus 6. Always check by foiling if you want. If you learn a different way, I don't care. Use it. It's fine. Another part of factoring is called difference of squares. So this happens, a squared minus b squared, when your factors have opposite signs. So a minus b times a plus b. It's a very special case. You could also find it by factoring like we did step 1 and 2. Or since it's a special pattern, we can just follow this. So this is a squared minus b squared. Notice it has to be subtraction, difference of squares. Well, b squared is 36. Notice that these are just b's. So the square root of 36 is 6. So in my head, I'm like, okay, this has to be a 6 and a 6. One of them needs to be positive, one needs to be negative, and we have our x's in front. Special pattern, always can check by foiling. Here, for number 9, I want to be very clear that, again, it's a difference, but both terms are squared now. The a is squared and the b. It might help to rewrite it like so. It's just an option. It's the same thing. This helps me really clearly see my a and my b term. It's the difference. So I can just plug into this formula. A is 2a, b is 7. And we just plug in. So one is 2a minus 7, and the other is 2a plus 7. This is a difference of perfect squares. For number 10, I'm like, oh, 216, is that a perfect square? I don't know, right? Well, hey, first, look for GCF. You should be doing that in all your problems. Here, I can take a factor of 6 out. That is super helpful because now problem 10 turns into problem 8 with just a 6 in front. Difference of perfect squares. One of them's negative, one's positive. And there you go with your factoring. We just have a couple more on the next page. Again, if you need help with any of these, if this is not sufficient enough, please come in for help. Part 4, there is perfect square trinomials, another special case. These occur when your a squared plus 2ab plus b squared equals a plus b squared. Special case. So what I'm looking here is like, hey, is 25 a square? Well, yeah, it's really 5. So I can rewrite this as 5w squared. 40, can I rewrite it? Let's kind of hold off for a moment. But can I rewrite 16? Well, yeah, I can write that as 4 squared. So perfect square trinomials, notice that it is a plus sign. Plus sign. Notice the a and the b value here can both be written as squares. Because it's a plus sign, I'm going to use a plus sign. So this really can just be 5w plus 4 squared. And let's do a quick check. Right? Let's check with that 40w. Is that actually 2ab? Well, 2ab, 2 times 20w, it is 40w. Again, if you notice these, use them. If you don't want to and you just want to factor, that's fine too. You can split the middle on this one as well. Something to notice for number 12 again. This can be rewritten as 3x squared. This can be rewritten as 2 squared. And it's a minus sign this time. So because it's minus, I'm going to have minus in my perfect square trinomial. It will be 3x minus 2 squared. Always double check that our negative 12x is what it should be. So it'll be 2ab. You got 2 times 6x. You get your 12x. And the negative sign matches from the formula. Check. Check. Okay. Our last part. I know this might be lengthy for some of you. Sum or difference of cubes. My acronym I want you to think of is SOAP. What you should all be using every day. SOAP. Same sign. So if it's plus, your first term is same sign, opposite sign, always positive. Same thing for if it's difference of perfect cubes. If it's difference, it's same sign, opposite sign, always positive. Super fun. Well, this is difference of cubes. So that means I need to rewrite number 15 as the difference of cubes. Well, 8 is really 2 cubed. And then 1, yeah, sure, 1 cubed. This is my A value. This is my B value, and I just plug into the formula. Because it's difference, I'm going to use this equation. And it goes just like this. Oops, maybe I should write it. Same sign, 2x squared, 4x squared, right, double it, I'm sorry, square it, plus AB times 1 if you want, plus B squared. So there we go. Same sign, opposite, always positive. And make sure you square the first term, multiply, and square. Next one, 14 is your last one. This looks like a sum of perfect cubes, but let's figure out what the cubes are. 125 is really same thing as 5 cubed. And that means x would be squared for our power to a power rule. So 5x squared cubed is the same thing as 125x to the 6th plus 4 cubed is 64. So 4b cubed is 64b cubed. This is my A term. This is my B term. It's sum, so I'm using the first formula. So it would be 5x squared plus 4b. I have to square my A value, so it'll become 25x to the 4th. I need to put a subtraction sign, A times B. That'll get me 20x squared B plus your B value squared, 16b squared. And that is your final answer with sum and difference of perfect cubes. Again, if you have questions, please ask. We're going to do a lot of practice, but still, if you need help, you need help. Let us know.